right, so let's go ahead then. So it is truly my pleasure to introduce Dr. Vernon Ruffin. I've known him for many years. He's been, doing things well beyond our, my dreams. So I'm really excited to get to hear from him again. So he's an assistant professor at Virginia Union University. He teaches embryology, physiology, and research methods to biology majors and biology for non-biology majors. Is that still accurate?
That is still accurate.
All righty. So, and that's at Virginia Union University, where which is actually his alma mater. He did his bachelor's degree in biology there. After that, he got his PhD from Howard University and went on to become a postdoctoral research fellow at Case Western Reserve University, so a few blocks down from us at CSU. And now he has his own research lab and research team at Virginia Union, where he focuses on the regulation of pH in the mammalian brain. So he has tons of accomplishments, and I don't want to steal his thunder. So I'll let him share what he's interested in sharing with us. So thank you very much, Brennan.
Thank you for that wonderful introduction. I thank everybody for showing up and celebrating the McNair Scholarship Program. It was a pleasure, as I said, talking with you the other day, reconnecting and being able to be a part of this event. So I'm going to share my screen and we are going to learn a little bit about, I guess, me and how I became at the position that I am at and some of the difficulties. So as Angel was referring, I'm sorry, I'm familiar with him, but as he was referring earlier, I met him at Case Western. And during the time at Case Western, he was trying to finish and I was trying to do my postdoctoral research. And so I'm going to talk a little bit about that research. Is my screen being seen? Can you guys see my screen?
Sorry.
Yes, we can see.
Okay,
Yes.
Great. Thank you. All right, so the title of my talk is My Nerve to Empower. And as was mentioned before, my research is about acid and the regulation of pH in the mammalian brain. And so just as an introduction, when I was approached, I was asked to talk about who I was and also my research interests. And so I am a visual person, and a lot of these will be, as my disclosure, pictures to show you my path. And then I'll get into some of the research that I've been doing and actually where I am currently. And so before I even begin, I'd like to acknowledge I have faculty members that are actually here from Virginia Union University. I also have my PI, or my boss when I was a postdoc, who has now entered in, and I just want to thank everybody for their support as we go forward. So this is my nerve to empower. Okay. So just to start off, I don't like to do the acknowledgements at the end. I like to recognize the people for the roles that they played in the beginning and in the middle, and as my career continues to develop. And so first off, I'd like to acknowledge God, and then I'd also like to acknowledge Dr. Walter Boron and Mark Parker. These are people that were in Walter Boron's lab. I also have some students, Avam and Austin, who I had a pleasure to work with. We also have Dr. Haddad, who is another one of the people who helped train me. And in his lab, I was specifically trained by Dr. Gu and Dr. Sun. And in addition, Robert Douglas was an instrumental person in the development of my career. And I'd like to also mention Robert KC. This is at Howard University, and Dr. Trough and Dr. Archer, who also were very instrumental. And so I'm actually showing here in the picture, Dr. Boron on the right, top right, and Dr. Haddad next to him. And I'm also showing Dr. Trough right here, who is my mentor at Howard University. And then this is me, of course, and then this is Dr. Archer. So to get into the talk, I can't do it without first acknowledging my family. So you see all of the Ruffins. I have my mom and my dad who are both teachers and very instrumental in making sure that I really focused and paid attention to education. And I have my brother who's an MD, and just the rest of my family, my wife, of course, and my daughter, and my nephew, and my niece, and of course my son. So before I can even continue, I'd just like to also acknowledge my wife who's watched me go through all of this, and she's seen the ups and downs and has been there to support me. So where do we begin? In high school, you couldn't tell me that I was not a basketball player, and I really had the defense and the pressure on this guy. And from that, here's the coach that actually is working with me. I learned about discipline, and I learned about motivation and to be self-disciplined. A lot of times when you're going through school, you forget why you're doing what you're doing. And so when you're growing up, it's very important to be involved in all of these different activities because it gives you character. And this character you need later as you go into your career. And so that was high school. But in college, you couldn't tell me I wasn't a rapper. And so I'm everywhere. All the traditional things that people see when they grow up, it's very important about exposure because people actually pursue the careers that they think are most relatable to themselves. So I was a rapper. My mom hated that shirt. And from college, I just wrapped up my high school and my college in one slide. While I was doing all of these different things, I had Dr. Archer here as my advisor, helping me navigate and pursue a career in neuroscience. And when I became a senior, that's really when my decision was made to actually pursue neuroscience. One of the most pivotal things that happened was, how you have these seminars and guest speakers come, like for example, what I'm doing right now. Well, somebody came from the NIH and they explained to me that if you wanted to become a doctor, they would pay for you to become a doctor. And I couldn't believe it. And I said, immediately, let me jump on this before they change their mind. So the requirements were to find somebody who had a lab and would allow you to work in the lab, and the NIH would pay for it. So I was able to find Dr. Susan Robinson, who was at VCU, right down the street from Virginia Union. And I was able to get in her lab as a senior and do very basic things in the lab, like take care of animals. And the research was way above my head. I didn't even understand what was going on, but I knew that I was now doing neuroscience. And this is all really about the connections that you make and the advisors and the mentors that you have as you're developing. If I hadn't talked to Dr. Archer to explain what my interests were, he would not have known that I was interested in neuro. And as a result, Dr. Archer wouldn't have put me with his advisor because Dr. Archer also had a degree in neuroscience. So this is Dr. Trough, who trained Dr. Archer, who trained me. And so this was the connection that I was making. And so I stopped by VCU to get some basic training in neuropharmacology. But once I got to Howard University and I was working with Dr. Trough, I became interested in neurophysiology, which is actually what I got my degree in. And so here's another way that networking took place. Dr. Trough knew Dr. Haddad, and Dr. Haddad was in Albert Einstein in the Bronx, New York. And because Dr. Trough wanted me to learn some different techniques, I was allowed to go to Albert Einstein, do a grant, and learn these techniques in Dr. Haddad's lab. And so, as I just said, I summed up my high school and I summed up my college all in one slide. And as you move through life, the things that happen, unless you actually capture them, it gets hard to remember these different things. So I'm glad I was taking these pictures. All right, so I'm at Howard and I just got into Dr. Haddad's lab and I'm going up to the Bronx to learn these different techniques. And what I noticed, it didn't take me the immediate thing, but what I noticed was in Dr. Haddad's lab, I was no longer in the traditional setting that I remembered at an HBCU. At an HBCU, was filled with people from your same culture, and it's really relatable. But now I'm in Dr. Haddad's lab, who was in the Bronx, who happened to move his lab out to California. So now I'm out in California, and there's only 3 Black people in the lab. You have my soon-to-be wife, Dr. Robert Douglas, who was also trained by Dr. doctoral at Howard. And here I am. And the rest of the lab is international people. So I was able to finish my research from Howard University using the research I collected at Howard University. And once I finished, I had to go back to California to finish the research Dr. Haddad had me doing. And these papers were published, in 2008. And from Dr. Haddad's lab, I flew back to DC and I got my degree at Howard University. So this was a very long road for me because I had been dealing with all types of financial issues as a student. You know, it's difficult sometimes finding even people to talk to or food for that matter. And so I finished and I was happy. So one thing that I did, which was I learned early about networking. When Dr. Haddad had these lab meetings, he would invite people from other labs. And one of the people he invited was Dr. Boron. And when Dr. Boron came to the lab and he was, during the seminar, when Dr. Haddad stepped out the room, I spoke to Dr. Boron. I said, Dr. Boron, I'm finishing up. And I'm from Connecticut. You're at Yale. I'm interested in going back to Connecticut and working for you because I'm interested in pH. Your lab is all about pH. I think it's a good fit. And Dr. Boron was nice enough to take me into his lab. And now I'm in Dr. Boron's lab, back at Yale, but then he moved his lab to Ohio. So now we're in Ohio, and what you'll see is that, again, I'm the only one that represents my culture. There's a bunch of different international people there and different cultures, and it's very good because the diversity that you have in a lab is important. Different views allow you to attack a question and think about it different ways you may not traditionally be thinking about. And so one of the things that I was doing, and I think this was because of the training of Dr. Trott, I would always be interested in trying to help people and empower people through research. And this is how Dr. Boron's lab looked when I first moved out there. I have this thing popping up. How his lab looked when I first got out there. And by the time I was leaving, I had additional people that I was training in there. So I have Austin right here, who was from New Jersey, and also Alam down here. She's from Jordan. And the lab was like a family. I really miss all of these guys, but as we move on in our career, we each go separate ways, but we maintain contact. So this is Boron's lab, Dr. Boron's lab. And I was doing really well. You know, I was a minority in a sea where that really didn't exist. And because of that, I would get highlighted. And this is Case Western saying, look at this program that we have, and we're training minorities. I'm actually the doctor in this picture, but because they're really pushing the promotion of these programs, and there weren't really minorities around, I was selected to be in this picture. So as I mentioned, I started training people, and this is Alam right here, and this is Austin. And the things that I knew, I would freely give, you know, and so I tried to teach Alam how to do the techniques that I was doing, and Austin how to teach the techniques that I was doing. I'm always feeling like I don't know, right? Because I know that in research, it's constantly pursuing a question, and you would be very vain, I believe, to think that you know all the answers. And so I would give what I knew, and I would ask for help, and I had no problem asking for help as long as at the end of the day, we got the job done. So in addition to training the people in the lab, Austin and Alam, I would train or work with minorities in other areas of the university. And this is similar to the program that I met Angel in, where you're in this environment and there's not a lot of people that look like you. So you look for these groups so that you can feel like some camaraderie. And each year I would train these students that were medical, dental student bound to learn how to do policies and public health issues. And each year, you know, these students are now doctors and dentists and all these type of professional things. But it was within me to constantly train people. And Austin, actually, I'm very proud of Austin. He's doing really well out in California. When I went to California, again, networking with Dr. Boron and Dr. Haddad, and I'm introducing them to Austin. And Austin, in this picture, you couldn't tell him that he wasn't really doing well. And so, you know, as you go through this phase where you are in school and finally get your degree and everything, you must remember to remain humble, because you stood on somebody else's shoulders and somebody's going to stand on your shoulders, hopefully. So I'm presenting my research, what, you know, traditionally you do in a lab, and you do the research in the lab, and the good time is that you get to take a mini vacation, which is you're going to present your research among your colleagues, and this is how you can do additional networking. So here I am presenting at one of the conferences, and what I would do, which I think is unique, whenever I would get around Virginia Union, my home institution, my undergraduate institution, I would go visit, because it was a family. HBC was like a family environment. So I would be more than happy if I was in DC to drive to Richmond 2 hours away to go see my chemistry teacher, or go see my molecular biology teacher, or go see my advisor, Dr. Archer. But the problem that, you know, Austin was a success story, I believe, and he's still climbing. But this is what I would return to after the conferences. I'm way in the back, you can't even really see me. There's not really a lot of diversity here. I mean, you do see a couple of people as we make these advances, but there really wasn't this diversity. And the stuff that I was seeing in these labs was amazing. Like, my friends would never believe some of the stuff that I was seeing. And not just so that people could see the things that are going on, but actually be in a place where they can help make decisions. Because as I said before, diversity is good for STEM because you have multiple different views. And so I would go visit my home institution, and I would say hello to everybody and go back to the conference and then go back to work. Actually, the topic that I had, I didn't know at the time, but it was very central to all of, you know, cell physiology. I was focusing on the regulation of pH in the brain. And because that's tied to so many different things in research, a lot of people were looking at my research. And so this is, I don't know how, if it's still these numbers, but I checked the other day and it was 83 documents had cited this particular paper. And within the particular journal, it was read more than 97% of other journals. And around the world, people were looking at my research. So what exactly is this research that I was doing? Well, before I get into the research, there was a time when the funding for the lab that I was in ran out. And so I went back home. And as I said before, my parents were teachers and they retired, but they still had that drive to teach. I guess that's where I inherited it from. So they had a camp called the Hartford Friendship Kids Camp that basically teaches kids in the summer about character. I think that's something needed nowadays. And while they had that camp and I participated in the camp and learned how to interact and give back, it was really important to give back. I was a substitute teacher and I was teaching students in elementary school, and I was seeing how they were exposed to so many different adult things that they didn't have an opportunity to be kids. And I didn't think I was doing much, but people were starting to recognize that I was trying to do something, and I was highlighted for some of the work that I was doing. But it wasn't something that made me feel satisfied, because as I was teaching these kids, kids were dying. Like, this is one of the kids that I had in 8th grade who was murdered. And so it's really difficult when you come from an environment and you're trying to open up the door and allow people to get through, but the environment that they live in takes that away from them. And so it really bothered me that this was a really wonderful young kid. Look at the dimples, right? He was a great kid. So I went back to Union. Dr. Archer was still there. And around the same time, I didn't mention here, but my daughter, I had a daughter when I was in college, and now I'm returning back to college as an assistant professor, and it's time for her to go to college. So it's kind of cool that we were able to go to the same school. Here she is right here. When I came back, Dr. Archer was running this summer program for minority students to help them in both math and science. And so she was able to benefit from that program because I was doing all.
Hand me my food. Why are you picking up everything?
Your shawl. Want your food, shawl?
Oh.
Okay. Can you guys hear me? I'm sorry, there was some complications.
Yes, sorry, there was a glitch here.
Yeah, okay. So when I returned to Union, my daughter was able to take part in the program that Dr. Archer was running. So not only did he help me in my career, he also helped my daughter. And the second year, this is the group. But what happened between year 1 and year 2 is Dr. Archer passed away. So this is my memorial to him, which I still have in the lab, because when he passed away, I inherited all of his responsibilities. He was a neurophysiologist. I was a neurophysiologist trained by Dr. Archer. And so I was teaching now physiology, and I was teaching the classes that he was teaching, and I was still learning, but I knew that I was well trained. And so if I want to talk about the research and what, why it's so impactful, I start from the beginning, and I have these slides just to make sure that whatever level you are at, you're able to understand why the research that I was doing had so many views. So this is your typical cell membrane, which has, just a phospholipid bilayer. And you know that there's a central dogma where DNA is turning into RNA and RNA is turning into proteins. And it's actually these proteins that carry out all of the functions within the cell. So it doesn't matter if it's a prokaryotic cell or a eukaryotic cell, they're all going through the central dogma. And what I've also included here are some of the ions that are present. You have sodium ions and you have potassium ions. And if you allow this protein, the sodium potassium pump, to sit in the membrane, exporting sodium and importing potassium, eventually you're going to have more sodium outside, more potassium inside. And again, here are these proteins that are being formed. These are big anions that can't get through the membrane. I just want to say here that things that don't have a charge can easily go through the membrane, whereas things that have a charge need some type of assistance, like for example, protein. So this pump is effectively separating these charges. Also inside of the cell, you have these organelles, and so the pump is doing this thing, and these anions are attracting positive ions. And you have organelles here that are involved in different types of things. Like for example, the mitochondria is being used to make ATP. You're breathing in oxygen, eating food, you're making energy in the form of ATP, but also as a byproduct, you're making CO2, which you're blowing out, and you're making a bunch of hydrogen ions. And so what happens with these ions? Well, these ions, they go to the membrane and they're trapped. Some of them go inside of vesicles and are used for digestion. Similar, in the ER, calcium is stored. So there are ways that the cell can prevent buildup of these ions by capturing them inside of vesicles. But for the most part, this hydrogen is trapped inside. So we know that if it's a neuron or a brain cell, neurons communicate with membrane potential changes. And so you have small membrane potential changes that can either be hyperpolarizing or taking the neuron away from firing, or depolarizing. And if you reach a critical threshold, you actually have what is known as an action potential. This is the communication unit of the nervous system. So what's happening? Well, you have sodium at the resting membrane potential. Sodium goes through sodium gated channels, and as it goes in, it makes the cell more positive. And potassium goes through potassium voltage gated channels, leaving the cell, making the cell more negative. And so you have this typical action potential where you have sodium going in, making the cell more depolarized, potassium leaving, making the cell repolarized. And this is the currency of the chemical, or the communication currency of the nerve cell. And so, as I mentioned, sodium is going through channels, potassium is also going through channels. You also have this sodium-potassium pump. And so really, these are the proteins that I have the lab focusing on in trying to understand how the nerve functions when it's impacted by changes in pH. So on a gross level or whole body level, the cell regulates pH using the lungs acutely, using the kidney or the renal system chronically, but within the cell also regulates pH. And so there's two major classes of pH regulating proteins. You have the SLC9 family, or the sodium hydrogen exchangers, and then you have the SLC4 family, or the sodium bicarbonate cotransporters. And the whole point is you're making acid. You want to make sure that the level of acid inside the cell stays constant. So it's really a balance of the acid that's being loaded or produced from metabolism and the acid that's being extruded by these transporters. You also have transporters that, if the cell becomes too basic, it gets rid of the bicarbonate. But it's the balance between the acid extruders and the acid loaders that determines intracellular pH, which is a measurement of the hydrogen ion concentration. And here are the two major families here. So what did I do? This was what I left Case Western with. And now I'm back as an assistant professor at my undergraduate university. But this undergraduate university is more or less a liberal arts university. There is no research being done at this university, but I have this passion to do research. So luckily, I'm able to, again, network, and I end up collaborating with a researcher, Dr. Carlita Page, and I'm able to get on a targeted infusion grant from the National Science Foundation. And through that grant, again, here, you see my daughters here. So through that grant, I'm able to infuse my research into the curriculum at Virginia Union University. So now instead of the traditional labs where students learn a technique, I'm having them learn the technique to try to use it to acquire data, to actually publish and advance the knowledge or the scientific knowledge in the field of pH regulation. And it took a long time because, students traditionally, they want to get an A, they want to graduate. And they're not really thinking about things that are in addition to their classwork. But because I was able to find a good group of students that were interested in research, I was able to start building a lab. In addition to the lab that I had, there were other faculty researchers in the department. You had Dr. Jackson, who represented chemistry, and Dr. Kababdullah, who did environmental science. And we had two physics people, Dr. Mensa and Dr. Kalitarians. And also we had molecular biology, Dr. Van Entropy. And so together we developed a faculty research corps at Virginia Union. And here all of us are in the summertime training students. And so this is a wonderful thing because now we're actually doing on-campus research. In addition, we're presenting. And so here we are in DC presenting, and social media is a really powerful tool. And so I'm using social media to display some of the research that's being done by the faculty at Virginia Union. In addition to the networking I was doing at Virginia Union, I was going around to all of the schools around there to try to find out who did neuroscience, because I want them to know that Virginia Union does neuroscience. And we have some really, really smart students. They just need to have an opportunity to get their foot in the door. So at VCU, I met Dr. Porter, and at UCLA, the team of Dr. Paul, and we also had Dr. Ayu at University of Virginia, and George Washington University, I had Dr. Nathan Smith. There's some additional doctors that I've met since then, but I'm more or less finding a core of scientists that are interested in training students that are minorities, or just in general, in STEM research, specifically neuroscience. So what happened from here? I gave the students projects. So here is Ms. Bianca Lockton. She's studying sodium hydrogen exchanges. And you have Ms. Kayla Easley. She's studying the potassium channel. We have Malcolm Lee. Mr. Malcolm Lee studying the sodium potassium pump. And of course, Michela Mondesi studying the sodium channel. And just to mention, these students, they're doing it because they are interested in research. It's not because they're on a stipend or they're getting financial assistance, although they should be getting financial assistance. They're doing it even when the financial assistance isn't available. So I guess the takeaway from this long-winded story about my life and the research that I'm doing is you have to develop self-discipline. This was something that I saw early as I was playing basketball, and as I tried to translate that from playing basketball to actually studying and applying it to my career. The same motivation that you would have doing something that you really, really like is the same motivation that you have or should have pursuing your career. And another major thing that I focus on with my students is time management. You can have all of the heart, but if you're late, then you missed your opportunity. I stressed hard that networking was very important. You need to find people that are supportive of your dream, like-minded people, people that when you stray from your dream, they can say, you know what, this is what you're supposed to do. Not in a malicious way or a mean way, but they're supporting you because they believe in you. And you want to believe in yourself that you have the ability to do all of these wonderful things that you're being trained for. Another thing, find a mentor or an advisor in your area of interest. I was lucky to tell Dr. Archer that I was interested in neuroscience. And with all of the mentors or advisors that I've had, I've been blessed because they have gone above and beyond what was necessary to train me. And even now, I'm still working with Dr. Warren at Case Western. You have to work hard. You have to work smart. Don't waste your time. Just because you're in the library does not mean that you're studying. And there have been times when I've read a sentence over, and at the end of the sentence, I still don't even know what I read. And that's a common thing. So you have to learn how you learn and cater your experience to that because you want to be successful and you don't want to waste your time. And in addition to focusing so much on your work, you have to make sure that you're balanced. It's important to pursue your career, but as you're pursuing your career, life is going by and you want to make sure that you're not missing opportunities. Work will always be there. And if something happens to you, you'll just be replaced because the machine is going to continue to work. But the relationships that you have, these are really important. And as I mentioned before, it's important to open up the door for people that don't have that opportunity. I think everybody has the ability to do something wonderful and they just need that opportunity. And so if there is diversity, you should encourage it because you don't know what people are thinking unless they're actually put in the position to perform. And if there is nobody that looks like you or has the same experiences culturally or whatever it may be, you've got to be that example for that person that's going to come after you to say, hey, that person looks like me and I think that I can do that. I mean, I was lucky in college to meet Dr. Archer and tell him, I keep saying that because I was headed to be a rapper and I was headed to be a basketball player. I actually got into school to be a basketball player, but I think I had a moment where I said, if I get hurt, what's going to happen to me? And so you really have to think ahead in the future to decide what type of life that you want to live. And the decisions that you make today are what are going to determine what type of lifestyle that will be. So work hard. And there are probably other things that I could have said to you to really let you know that it's important to be serious about your career. But I think you get the gist that you got to work hard and you have to think about your future. Make sure that people are there to support you. And even if nobody is there to support you, remember that this is your dream. And nobody's going to be as passionate about your dream as you. And so be encouraged and that is the end of the talk. If anybody has any questions, please feel free to ask them.
That was a wonderful presentation. Thank you very much for sharing all this